Dinitrogen and dihydrogen reacts with each other to produce ammonia according to the following equation. Calculate the mass of ammonia produced if 2 into 10 power 3 gram of dinitrogen reacts with 1 into 10 power 3 gram of dihydrogen. Okay, so here in this question, nitrogen reacts with the hydrogen to form ammonia. Dinitrogen is nothing but N2. Okay, so we'll make it to be a stoichiometric equation, that is a balanced one, right? So already it is given in the question. And one more data which is given is, you are given the mass of nitrogen. Mass of nitrogen is 2 into 10 power 3 grams. Similarly, you are given the mass of hydrogen, that is 1 into 10 power 3 grams. You are asked to find out the mass of ammonia. So this is a question mark. Okay. Firstly, you have to remember all the reactants which are taken in the reaction vessel will not undergo reaction. So reactants will react with each other according to the stoichiometric ratio. What is that? So this is a stoichiometric equation, right? That is balanced equation. So according to this equation, 1 mole, nothing is there, which means 1 mole, right? So 1 mole of nitrogen is reacting with 3 moles of hydrogen to form 2 moles of ammonia, right? Then in terms of mass, if you represent every nitrogen, N mass is found to be 14, since there are 2 nitrogens. So 2 into 14, you will get 28. So 28 grams. Similarly for hydrogen, one mass is found to be, it is 1 gram. There are 2 hydrogens. So 2 grams. Since there are 3 moles, 3 into 2 you will get 6 grams, right? 6 grams. So 28 gram of nitrogen is reacting with 6 gram of hydrogen to form. Similarly for ammonia, I can calculate nitrogen mass is 14 plus hydrogen mass is 1. There are 3 hydrogens. So 3 into 1 you will get 3. So 17. So 17 is for NH3. Since there are 2 moles, so 17 into 2 you will get 34. So here 34 gram of ammonia. This is the stoichiometric mass, right? This is the stoichiometric mass. This is the one which is given in the question. The reaction vessel you have taken like this. So how much ammonia will be formed? So remember, whatever you have taken in the reaction vessel will not undergo reaction. They will react according to the stoichiometric ratio. So how to find out? How much is required for one reactant to combine with the another reactant? So how to find out? That is using this stoichiometric ratio only. So according to stoichiometric ratio, 28 gram of nitrogen can consume 6 gram of hydrogen. 6 gram of hydrogen. But in the reaction vessel, you have 2 into 10 power 3, which is nothing but 2000, right? So 2000 gram of nitrogen can consume how much gram of hydrogen we have to find out. So nitrogens are all in the same side, left hand side. Hydrogen you are going to calculate in the right hand side. Therefore the ratio will be this into this divided by this. So 2000 into 6 divided by 28. When you calculate, you will be getting 428.6 grams, okay, grams of hydrogen. So in the 2000 gram of nitrogen can react with it needs only 428 grams of hydrogen to get reacted. But in the reaction vessel, we have 1000 grams of hydrogen for reacting with the 2000. So already it was told all the reactants which are there in the reaction vessel will not get reacted. So actually 2000 gram of nitrogen needs only 428, this much only. But we have in the reaction vessel 1000 grams of nitrogen is there. So the hydrogen is found to be excess in the reaction vessel. So this is known as excess reagent, and this one is known as limiting reagent. The one which is less in quantity is known as limiting reagent. So here nitrogen is the limiting reagent. Limiting reagent only will decide the amount of product which is going to be formed. So based on limiting reagent, you will be finding the mass of ammonia which will be formed. So now we can again take the stoichiometric ratio, that is 28 gram of nitrogen will produce 34 gram of ammonia, right? In the same way, therefore how much is there with you? You have 2000 gram, right? 2000. Therefore 2000 gram of nitrogen can produce how much gram of ammonia? So nitrogens are all in the same side, ammonia are in the same side. You can write the ratio, this into this divided by this. You will get the mass of, if you simplify, you will get the mass of ammonia.